Ja, skulle være lyd igennem. Vi skal, det her vi jo kommet til. Vi skal lige bruge det her til at vende det hele om en gang. Thank you, D.R. Let's turn to the language of the course, which is not Danish, which is English. Here we are. Thank you for stopping me there. Determination of sample size. Now, we have a formula. I mean, maybe you still, of course, you have to get used to this formula a little bit and what it really means. That's fair enough. But at least you could see it. Here is a formula that gives us some kind of error statement when we have an average. And it is related to probability. Fine. So if we know the noise of the system, if we know how many observations we have, and if we already did the experiment with the 25 drives, of course we know. Then we can compute maximal errors according to this formula. This we can use, this theoretical results, we can turn it around before, when we were in the planning phase. Screen is not shared. Here's my screen. We can turn the formula around and isolate n in this formula, right? Put z and sigma on the other side of the equation sign, and then we isolate n. It's the same sort of terms, we're just isolating n. We have this classical, one of the classical sample size formulas, stating the following, that if we have, let's do an example instead of me putting words on it. The same story once again. Here is, now you're in the planning phase, so you're in front of that, you're going to find out how many test runs or test drives are you really going to take for you to find a suitable knowledge here. And this is an important phase also as when you're a manager on this whole project out there, because this is money. Am I going to have him drive for 2 days or for 2 weeks? That's a large difference in money too. So we have to consider how much of an information am I interested in actually achieving here. For instance, here's the question or the task. Determine the sample size, that is the amount of drives, the amount of runs, that we need to attain a certain level of certainty, to attain that the maximum error, the 95% maximum error, is 0.10, right? So we specify the needed certainty in the case. Then we can take n, we should take set 0.025 because we use, again, alpha 5%. We should take, I just forgot the formula, here it was, we should times the standard deviation divided by the E, the required E, the maximal error. So we agree that this is the formula that I just had. And then this number, as you remember, is 1.96. So let's try to compute this number. I think I had this prepared in R. Here's this number, 1.96 times 0.2 divided by 0.1 squared. Let's see what the number is. It's 15.4. And then if we want to make sure that we're on the right side of the certainty, let's go for 16 runs, not go below. Let's round up to 16 runs. That would be the answer then. So if I know the noise of the system, sigma, and if I have some specification of precision, I can decide my experiment like this. This is something everyone should be thinking about whenever you start experiments, actually. Not all of us do all the time, but you actually ought to. Because why spend $1 million on some experiment, and then at the end of the day or the end of the year, you realize this experiment would not be able to detect or find anything of interest anyway, because the amount of noise is too large compared to the amount of observations that I could achieve for 1 million. I need to think about how much information can I achieve for 1 million before I throw the 1 million at doing it, right? Common sense, but difficult sometimes. That was the sample size part, so we jump to the next part.